Seat there, or seat here, seat over there, wherever you like. Just keep in mind, you'll have to turn to see me right there, okay. There you go. So just start filling out the top of this, and then you're going to share the markers over here and just kind of fill out your schedule. Yeah, it says it's color coded on the bottom here, and you'll use those markers. See how he's doing that? Yeah. You can have these. I don't think there's every color in there, but you can get started. I'm seeing a lot of pink. No, I'm just kidding.
Well, somebody's got to sleep sooner or later.
Too much sleep. You just have like one line of pink? That's it? I won't be checking to make sure you're telling the truth, okay? I'm not going to go look up your class schedule or anything.
That one teacher you told us actually did. Last semester you said there was an actual teacher that checked them.
Well, maybe. I don't remember. I don't remember that. I don't remember that story. Probably going to give you another 5 minutes. And if you don't finish, at the end of class, you can finish. It's okay. Just excuse me. Is everybody about done? No? You need what? Yeah. Someone say something? Someone's throwing their voice. Oh, borrow yellow. I heard it right there.
What time is this place usually open?
Which place? 316, the tutoring lab. Actually, I think it's 8 a.m. to 7. Till when? I think it's 7 or 8. They have the hours on the posted. All right, I think that's sufficient time. My name is Robert D. Giovanni. I'm the instructor for this course, Cal 1. Everyone's in the right place, right? So the point of that little assignment, again, I am going to collect it because I want to give everyone a free 100. It's going to be a free quiz grade right there, just for filling that out. I'm going to make a copy of all of them, and then I'm going to give them back to you. And really, it just comes down to one of the things that I run into almost every semester is somewhere towards the end, I have a student who's really at the point where maybe they're not going to pass, and we get to talking about, you know, how did it come to this? And it's almost inevitably going to be time management. It's always, well, I just don't have the time. I work and this and that and this and that. So I thought it would be important for everyone to just take a picture, a snapshot of their week, and just be realistic about how much you're trying to do. I mean, there is a reason why you can't get a 4-year degree in 1 year, right? There's only so much information that a person can process in a certain amount of time. Same with every semester. It's the same thing on a smaller scale. So we don't drink out of fire hydrants, right? We drink out of water fountains, right? And it's the same thing. So I'm going to look at them, and if I see a little bit of yellow in there, and I see a bunch of other orange and blue, it means you're working too much, you're taking too many classes, and you don't have enough time. And I'll just probably circle it and give it back to you and just be like, that's kind of me going, hey, red flag here, I see issues, you know? But everyone can handle a different amount, so, you know, maybe you can do that. I remember I had a semester where I was waiting tables on the weekends, and I took 24 hours of courses that semester, 8 math classes, all math classes. So it can be done, I know that. It depends on how focused you are and how determined you are, and so there's a lot of variables here. So I'm hoping because this is Cal 1, everyone here is capable of focusing, and that this is not going to be a babysitting thing here where I'm trying to encourage you to do your work. I mean, you should know at this point what you have to do well. So, okay. Y'all want to turn those in now? Yeah? Okay, if you don't mind, the little bag there, if you could just throw the markers in there and pass the bag around. There we go. Thank you, thank you. You ready?
Hand these back, or
Yeah.
you hand these back?
Yeah, I'm going to give them back to you.
Okay.
Yeah.
So I
Yeah.
get the yellow in. Like,
Yeah. Yeah, you can finish.
All right.
Thank you. Anyone else? All right, I'll take the bag. Got it. Here we go. And if y'all could just pass that around that way. Just make sure you get that to me so I can give you a grade when you're done. All right? All right, well, welcome everyone to Calculus 1. Welcome. How are you feeling about this? Whoa, what the hell is that? What are you thinking? You've heard about this course? Do you have any preconceived notions about, what this is going to be?
Easier than pre-cal.
What's that?
It's easier than
Easier than pre-cal. Okay.
I hope so.
Interesting. You're hoping or you've heard?
I'm hoping.
You're hoping. Okay.
I've also heard fancy algebra.
Yeah. Anyone else heard anything about this? It's nothing like pre-cal. Yeah.
I was wondering, I was told in the bookstore that the book is supplied. Is that true or not?
They lied to you. The book is supplied.
That's what they said.
It's supplied by them.
Okay.
Yeah, this is it right here.
I had a feeling.
Yeah, they may have thought that you were in an online class maybe or something. Okay. All right, so yeah, pre-cal's nothing like, Cal 1 doesn't really use much pre-cal. I've heard that. Anything else?
Fancy algebra.
Fancy algebra, where have you heard that? Oh, I told you that. Okay, I'm sorry. Yes. That's true. All right, well, yeah, Cal 1, you know, my impression of Cal 1, I have the impression as a student, and I have the impression now that I'm teaching it. So when I was a student, my whole view on it was like, this is supposed to be the hard math. Like I was intimidated by it. And I didn't tell anyone that, but I mean, that's what you were told. That's what I was told growing up, calculus, like you shiver when you say it. And it turns out that, I think that the concepts in calculus are not the thing that makes calculus difficult. The concepts are pretty easy to absorb by most students. When I say easy in here, I'm not speaking from my point of view, I'm just speaking in general, all right? So they are easier concepts. It's the algebraic manipulations that are required, the algebra, the trig, that's just assume that you know. And so the pre-cal, yes, it's very different than this course, but anything that was in pre-cal is fair game. So if we just start solving trig equations in the middle of a problem, that's because you should have been able to do that in pre-cal. So we're going to pull from everything, and nothing's off the table. Understand? So when we go and all of a sudden we're doing a completing of the square on something, you're like, well, wait, it's been since algebra. The expectation is that you remember it like you just took algebra. And that's what makes it hard, is that you have to be able to pull from all these resources in your mind, and so you might have to get freshened up on things. Any other things you've heard? How about Cal 2? How many of you need to take Cal 2? Wow, okay, how many of you Cal 1, this is it? That's about the last, I teach another Cal 1 on Monday, Wednesday at 11, and they had the same ratio. It was about 90% needed Cal 2. What have y'all heard about Cal 2?
It's nothing like Cal 1 and it's craziness.
Yeah. Anyone? No, you haven't heard anything? Okay. I don't know if I should tell you anything. Do you want to know anything about Cal 2? Okay, Cal 2 makes this look like baby play. Okay, now I don't mean that in a bad way. I just mean that when people are in Cal 2, they are not ready for that pace. Even if you're a good Cal 1 student, the pace of Cal 2 is where you really separate students. Like that's where you start to find out, like, is this the right degree path for you or not? Now, again, it's doable, but it's just, you know how everything is relative, right? When you're taking pre-cal, you kind of wished you were back in college algebra because it was just, maybe not, depends on your teacher, but everything is kind of like a step up, right? Well, Cal 2, that next step is pretty big. And the best analogy I can use to describe Cal 2 to you is that Cal 1 is a forward process. Everything we're going to do in here is a forward motion. Okay, so you learn to walk, right? You're moving forward. And Cal 2 is basically everything in reverse. So we're going and we're going backwards, doing everything we were doing Cal 1 backwards. And the only way to be able to do that well is if you were really good at going forward. Understand? Because Cal 1, it's going to be a lot of formulas, a lot of steps, procedures. I call it mechanical math. It's very mechanical. I give you some formulas, and then you learn these rules, and then you just apply the rule, and it's like, bop, 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 you're done. Cal 2, you look at a problem, and you actually have to see that came from some rule that you used in Cal 1, and kind of undo it. It's puzzles, and it's hard to teach people how to think that way. It's easy to teach someone how to follow this procedure, but it's hard to teach intuition. Okay? So the reason I bring that up is because I want everyone to focus throughout the semester that what you learn in here from day 1 all the way to the end will be important in Cal 2. Okay, so if you struggle on one of the exams in here and still pass the class, that doesn't mean you're good to go for Cal 2. You need to go back to that exam you struggled on and master that material. You've got to do that, or else you'll be dead in the water in Cal 2. Okay? I'm not trying to scare you. I'm just kind of a realist. I want everyone to be realistic about things. Okay. All right. What else? I'm recording all the lectures, so this camera will be in here every day. And after class, I'll go down to my office. I'll upload it to YouTube. It'll be unedited. It'll just be the way it happened here because I don't want to spend time editing videos. So you can go and watch it later on that night if you want to go back and review for a test. I'll list it by the day and this. I don't know if I'll put the section. I don't know what I'll put. I'll just probably put 24/13, Tuesday, Thursday, day 1. And there will usually be 2 videos per day because it automatically partitions the video after a certain amount of time, so 2 videos per day. Got it? So if you miss a class, that's fine. That's really 90% of the reason I do this is for the student who gets a flat tire, has a death in the family, they can't be here, they're a good student, they just couldn't be here, that you won't have that hour, 40-minute gap where you just don't know what happened. You'll at least have that as a resource. It is not a substitute for being in class. I am required by the state of Texas to take attendance because this is a public institution and it's funded by taxpayers, and they want to make sure that the people who are paying are here and all that stuff, so you need to be here. You get 4 absences. After 4 absences, you can be dropped from the class. All right, I need to talk about the syllabus. Unfortunately, we have to invest time in that. But it's important because it's our contract, right? It's the agreement that we have about the way things are going to go in here. But I thought maybe before we did that, I would just kind of peek into Cal 1, just kind of where we're going with it. And I can get really deep into far into the semester where we're going to go. But I think initially, I just want to show you what the basic premise, the basic problem is, all right? What we're trying to accomplish with calculus. Calculus was discovered by, created by, invented by who? Anyone know? Father of calculus? Isaac Newton. And there was another gentleman named, last name is Leibniz. L-I-B, it's in the book, okay. Those are the 2 fathers of calculus. It's kind of amazing because they both developed calculus at the same time in separate parts of the world. And they were totally unknown to each other. And then they, at some point, go, oh wow, we were talking about the same thing. So at that point in time, there was no calculus. So Isaac Newton and Leibniz were trying to get around a problem. There was this continuing issue that they were trying to address, and from it, calculus was born. Here's the problem. 0 divided by 0. All right? Now, we know this already. If you take something like, let's say 0 and divided by 4, we know that's 0, because you can always have a number on the bottom other than 0 and divide, and if that's 0, well, that's 0, right? We're all comfortable with that? If I flip it around, 4 over 0, that's what? Undefined. Now, I'm going to be very clear, all right? That word undefined is a very special word. We use it in a scenario like this. There are other times that we're about to talk about today where something similar is going to happen. We're not going to use the word undefined. So we reserve undefined for certain things, and then later on we'll have another word for something else. So the semantics here are important. This is undefined. We cannot divide by 0 in our number system. So then you look at something like this, and what do you think? If I try and take 0 and divide it by 0. Undefined?
It's kind of like, you don't have anything, you're dividing it by anything.
So are you going to say undefined? I'm not asking you to give me an answer. You volunteered. Are you thinking that's undefined?
Well, I'm sure I'm going to say yes.
Okay, go with yes then. Go with your gut. That is correct. It is undefined. This is undefined. However, there's a way that we can get around this. All right, and that's what Newton was trying to do. He's trying to get around, because this kept on popping up, 0 over 0, 0 over 0, 0 over 0. And he was trying to get around it. And the way he did it is by introducing this thing called the limit. And that's what we're going to talk about today. But I want you to see where this comes from, all right? I want you to actually see where that 0 over 0 actually crept up. And I'll give you an example of something that I think we can all relate to. I hope we can relate to. Let's say that this is time, and let's say that this is distance. And let's say time we measure here in seconds. Oh no, we'll do hours because that's something we all. Let's say distance is in miles. So I'm about to graph this, this drive I took to Austin, okay? So I started out 0 time, I had gone 0 distance, right? And I drove and, you know, slowed down, sped up, slowed down, whatever. And as I was moving around, I eventually got to Austin. Let's say it took me 2 hours. And let's say the distance I went was, we'll make these really easy numbers, okay? 100 miles. I went north of Austin, okay? Easy numbers to work with, all right? What was my average speed? 50 miles per hour. Right? How did you get that? You just thought it? 100 divided by 2, no big deal. All right, but geometrically on this graph, if I connect this point to this point, I create what's called a secant line. Secant line. A secant line is any line that passes through 2 points on the curve, all right? We're going to call that a secant line. If you have a straight line, we can always define the slope, can't we? What is the slope of a line defined to be? So the slope, we used m, right, back in college algebra? The slope of that secant line, I'm going to put SEC, slope of the secant line there would be the rise over run. I heard that. I agree. Rise over run. And what would the rise here be? That would be the change in your y coordinates, right? So if I looked at this as being a point, 0, 0, and this one as being a point, what, 2, 100? Y'all with me? Then the rise over run was like this formula. Remember this? y2 minus y1 over x2 minus x1. Remember that? It's like you take the difference of the y coordinates, divide by the difference of the x coordinates. That's your slope. And this, in this case, would be 100 minus 0 over 2 minus 0, which would give you your 50. So it turns out that your average speed that you said 50 miles per hour is also the same as the slope of that secant line. Agreed? Okay, this is not calculus. This is college algebra. So where does the calculus come into play? What we're interested in trying to define is what's called the instantaneous speed, not the average speed, the instantaneous speed. We'll actually call it the instantaneous velocity. Is it possible for you to talk about the speed of an object at an instant in time? Yes? I saw a no and I heard yeses. How do you define the speed at an instant in time?
How fast that person's going at a certain.
Okay, so let me pick a point here. Can I pick a point? Right here. And let me just call it, just for the sake of it, x, okay? And so I go up here on this, right there. At that point in my driving, did I have a speed at that instant? Yes? How do you calculate it from this picture? I mean, like, it was easy to get my average speed. I just found the slope of that secant line, right? But how do I find the speed at that instant off this graph?
Zoomed in on it, sectioned it off, so you can just pull the secant on that one portion.
Okay, good. I really like that perspective. Just kind of zoom in on it. Okay, let me zoom in for you. I'm going to take this, and I'm going to zoom in on that. Here's your graph. Here's that big old point. And what do you want me to do?
There. Now it's a straight line, right?
That's not straight. It's still
Well,
curved.
It's pretty straight. It's pretty.
Oh, you want me to zoom in, and keep zooming in until the curvature on this thing is like negligible? It's basically straight.
Right, so you can actually put a secant against it to probably make a curve on it.
I like that idea. Do y'all like that idea? I mean, you'd have to zoom way in, right? How far in? I mean, that's kind of, we start to come in with this ambiguous term of what it means to be really zoomed in or like really close. That's very ambiguous, isn't it?
Because you can zoom in infinite
Yeah, you could keep going, right? A point has no width to it. A theoretical point on a piece of paper has no width, has zero width. So I zoom. I really like that perspective. I don't think I can remember a student actually telling me to do that. That's a good perspective. I think what you want to do is you want to get so zoomed in that you can do a secant line here and it's good enough. Is that kind of the idea you have?
Yeah, I would do that, or either that or try to use a tangent line.
Well, that's what how do you find the tangent line though?
Oh man,
Yeah. Okay, so good. No, but this is what we need to be thinking, and that's what I need from you. I need feedback. This is good. So look, let's address it this way. If I were to pick, so keep that blue point where it is. If I were to pick this point right here, then if I connect these 2 points with the line, that would give me the average speed on this little interval of time, wouldn't it? Between the blue and the green. The line between those, that slope would be the average speed just on that little interval. Yeah? How could I get a better guesstimate of the speed at this point? Yeah, picking a point that's closer, right? So I pick a point that's even closer, and I draw a line through there, secant line. Now that would be a better guesstimate, right? And then how would I get better? Just keep on moving it over, and that's where you're saying zoom in. We zoom in, we keep moving a point over and over. But if you want the speed at that instant, you've got to eventually get that green point on top of the blue point to be talking about an instant, don't you? Let's take a look at what this formula right here looks like if I put the green point on top of the blue point. What happens? If the green point is the blue point, then what's your change in y? Zero. What's your change in x? Zero. You get 0 over 0, right? And that's undefined. However, if we just barely nudge that green point off to the side, just a little tiny bit, we will have a definition of a slope, right? As long as they're not right on top of each other. Yes? So Newton said, look, there's obviously a speed at that instant. There's got to be. How do I find it? Because I can't put the 2 points right on top of each other. So what he did is he used this thing called the limit. And what he did is he allowed this green point to slide closer and closer and closer and have this like infinitely close, get infinitely close to that blue point without actually ever getting there. And that's the idea of the limit. It's letting something do something but not ever have to actually get to this point. It's a limiting value is going to come out of this. And so we can get, you'll have to believe, we will be able to get the speed at an instant. We will be able to get instantaneous velocity of an object. Now, that translates into all sorts of things because what we'll be able to do is use this idea of being able to compute this line to do which will be called a tangent line, by the way, later on. We will be able to look at any graph, doesn't matter what it is, okay? As long as it's two-dimensional. We'll be able to look at any graph, and at any point, we will be able to figure out the slope of this line that goes through at any point we want on the graph. Yes?
Are a lot of the answers approximate, seeing that it can't?
No, they're exact values, yes. And that's, again, the beauty of the calculus and the beauty of the limit and the beauty of the real number system is that if your values are headed to something, it can only head to one thing. And that one thing it heads to is the answer, and it's an exact value. You're guaranteed by what's called the completeness axiom of the real numbers that you're not going to be head somewhere and all of a sudden it's going to go somewhere else. It's beyond the scope of this class, but we can be sure that it's an exact value. No approximations here. So if we can go to any graph and we can find these tangent lines anywhere on a graph, then if you think about it, we're going to be able to do some really cool stuff that we couldn't do before. I think you all know from college algebra that with a parabola, we all knew what that point was. It's called the vertex, right? And there was actually a formula to get it. But then after parabolas, they talk to you about cubic functions, polynomial cubic functions, right? Something like this. And we actually drew these in college algebra. But one thing we never did was try to figure out these points because we couldn't. We couldn't figure out the highest and lowest points on polynomials. We couldn't do it. And the reason we couldn't is because we didn't have calculus. But see, in calculus, we're going to be able to find all those lines anywhere we want, right? What can you tell me about that tangent line that would be right there? What can you tell me about its slope?
Probably like 0.
It is 0. It's exactly 0, isn't it? It's a flat line. And right here, it's a flat line. In other words, if we can figure out where those tangent lines have a slope of 0, then we will be able to regurgitate out where it came from and be able to find maximums and minimums of functions, any functions. So that again starts to blow the doors open on what you can do. You give me a function, I can tell you exactly where it's its highest and lowest. Let's say I want to
So are the zeros usually on maximum and minimums?
are the zeros where the tangent line 0? It could be a maximum or minimum. It is possible to have a slope that's 0 and it not be a maximum. You can have something like this. And you can see here it would be flat, but that's not a maximum or minimum. So we'll have to check, we'll have to test. There's some, we call them the first and second derivative tests, and we'll have a process, okay? I said I wasn't going to go too far into it. Let's say that I want to build, this is a top view. This is one of the classic problems in Cal 1. I want to build this enclosure. I'm a farmer, okay? This is the farmer problem. You have, let's say, 300 feet of fence, okay? And I want to build these rectangular enclosures to put my whatever, pigs, chickens, whatever, in these 3 equal enclosures, right? So this is fence, fence, fence. 300 feet of fence. I would like to know how to build it so that I get the most area. So think about how I could do this. I mean, I could do, let's say, 100 here, 100 here, right? That'd be 200 feet, which would leave me how much in here? For each of those, I have to build 3 sections. Like 33.33, 33.33, 33.33, right? Sorry, no. Yes. Let me throw one more in there. I drew my picture wrong. That's the one. How many? 1, 2, 3, 4. We have 100 feet. So what, 20 each?
Yeah.
Apologize. Right? That's one way I could do it. It's my first day back, okay? Give me a break. 25. Okay. We all good? What's the area of this? What's the total area of the enclosure? Well, how wide is it? How long is it? 100. So that's what? 2,500 square feet, right? Is that the best way to do it? Could you do it another way and get more area? Yeah, maybe? Or is it all going to be the same no matter how you do it? There's infinite ways you could do it. I agree. So let me just look at another scenario. I could have done 50 here, 50 here. Right? I could have done that. That would have left me how much for in here? 200. So I could do, these would each be 50, 50, 50, 50. I could do it that way, right? What's that going to give me? What is it? 2,500? So maybe it is the same no matter what. Is there anything else I could try? Infinitely many ways, right? I need to do one more because I don't want those to come out to be the same.
Different shapes?
No, we're sticking with the same shape. Let's try something different. How about 75 and 75? How much is left? 150, which I have to use for these 4. What is it? 150 fourths? That's an easy way to do it, right? 150 fourths, 150 fourths, 150 fourths. What's the area of that? Go ahead. What's that? I'm going to break out my phone.
2,812 feet.
What is it?
2,800 square feet.
2,800 square feet. Oh, that was better, right? That was better? So what's the best way? Now, we could sit here all day and keep trying different things, right? Very inefficient. Very inefficient. Instead, what we do is we come up with a function, area. An area function. We define a function. We just say, hey, let's let this be x. Let's let this be x. And that's x. All right? How long are these? Yes, we call them y, right? But we can do even better than that. I'm reaching today, okay? I'm reaching a little bit right now. So if these are x, how much fence is still there? 300 minus 2 x's. That's how much fence I have left, right? Right? Each of these have to be equal. How many of them are there? 4. So would you agree that this side would be 300 minus 2x over 4? Yeah? Each of those. What's the area of this pen? This times that, right? Distribute through. That's a quadratic function, isn't it? Can you tell me the maximum of a quadratic function? It would be the vertex, wouldn't it? We could actually answer this problem pretty easily. We're not going to, but imagine that we try a problem like this. What I'm trying to get you to see is that we have a real world problem, even though no farmer's going to do this. We have a real world physical problem that we're trying to find an optimum solution for, right? We could trial and error it. It's a waste of time. Instead, we come up with a function. Once we have a function, doesn't matter what it looks like, we'll be able to find highest and lowest points on it using the calculus. So we can do these things called optimization problems. Find the cheapest way to lay fiber optic cable from here to SeaWorld. The cheapest way to do it. Well, you got to go underground, right? You got to go under roads. You can go above roads. You can go above ground. Different costs for different things. You can find the best path, the cheapest path by using optimization. So, all right, I've gone way too far into where I wanted to go. I was just trying to get you to see the 0 over 0 problem. I don't know how I got to this, but I hope you're intrigued a little bit. We have to talk syllabus. I'm assuming that everybody knows how to get to Canvas. If you don't, please talk to me after class. Does this still happen for you all?
Yes.
What a pain. You have to select fall 2016. I am teaching a lot of classes. What are you here? Section 22? I think you are.
022.
Yes, you are. My Monday, Wednesday class? Yeah. All right, you have an assignment due tomorrow. It's a confirmation quiz. All you have to do is click on it. It's a yes or no question. It's just you signing the syllabus, saying, I understand. Okay, that's due tomorrow. Yeah, and then that other quiz grade. So these are easy quiz grades, right? Look at that. You're already starting off at 100. I've got a 4.0 in Cal 1. You can say that right now. All right. All right, so now let's talk about the schedule. So the schedule here, you can download this. I recommend you download this and print it out, bring it to class. This is my my tentative, I'm sorry, I tried to get it all on one page. You have to use a magnifying glass. This is what I'm going to attempt to do as far as the time, all right? Every day, what we're going to try and do. These are the problems you're going to be doing at your homework, all right? For homework, you can try all these problems. So for each section, just go do those problems. We have an exam on September 13th, another one on October 11th, another one on November 15th. Last day to drop is November 11th. And then our final lands on a Thursday, which is good because that means you'll have a week between our last day and the final, a full week. Questions on the schedule? You have homework tonight, yes. Yep, it's out of the book. Man, it's kind of hard to read this. Hold on. Make it a little bigger. All right, so all the videos that I'm doing here, as I post them, they will appear here. You can just go course videos. That'll take you to my YouTube channel. And this is the course video. Oh, wait, hold on. What is that? Oh, yes, I'm forgetting. We have two types of videos in this class. Actually, three. Course videos are videos that I've made for you to watch before you come to class that prepare you for the material we're going to cover. So like today we're supposed to cover 1.3. Theoretically, if you would have known this, you would have watched Chapter 1, Section 3, Limit of a Function before you came to class. This video is 24 minutes long. Now the videos vary in length, all right? Some of them are short, some of them are a little longer. You watch that way when you come in here, what I'm saying is not like brand new. You've at least heard me talk about it once before. It's kind of like reading the book before you go to class, except I'm going to read it to you. All right? And I'm going to pull the things that are important out so you don't have to sit here and decipher the book. All right? So that's like pre-material. Those are called course videos. I will also mention Chapter 1, Section 1, Chapter 1, Section 2 are not on the calendar, but there are videos for those. These are review topics over functions and then essential functions. So these are the things you should know. Power functions, trig functions, just to kind of like remind you if it's been a while, like these are the functions I'm going to be talking about and you need to be familiar with. But officially, 1.3 is where we're starting. All right, so those are the course videos. Then you have the class lecture videos. That's what's coming off that camera. And right now, there will be nothing here. Okay, so the videos will start to appear here as I upload them. Make sense? Homework solution videos. This is new. This is brand new. Okay? I just decided I was going to do this about 2 days ago. I'm going to work out all the homework problems on video. Okay? Not all. If there are 3 problems that are similar, I'll do one of them, and then the other 2 I'll say, hey, you try those, okay? But each time the concept changes, I will do a problem similar to it. I am ahead of the class right now. I've already done your homework tonight. I've done the homework for what you're gonna have on Thursday, and I've even done the homework for next Tuesday. So look at me, all right? I'm trying, okay? Look at these videos, 45 minutes, 52 minutes, 43 minutes, and I'm not even doing the whole assignment, and I know what I'm doing, okay? So, what you should do, the way you should utilize these homework videos is as follows. You get your homework assignment out, you go to number 1 or whatever problem it is, you bring me up, and I've already watched some of this, so here's number 1, and you click pause, and you start working, and then maybe you say, I don't know about that step, and you follow through, and that's the proper way to utilize the video. If you just want to sit there and watch me and think, okay, I see him do it, I get it, I can do it, good luck with that. If you're not going to try the homework yourself, good luck with that. No one has ever been really successful with not just watching and not doing. So I hope you find this as a useful tool. Wow, I already have 24 views. Oh, my other class, my Monday, Wednesday class also has access to these videos. So look, They're on top of it already. They're utilizing it. That's a good thing.
24 students and
Right? I don't. Let's see if anyone's been real eager. I just posted these about 2 hours ago. Two views. I think those are both my views. Okay. So look, those are the 3 videos. Do they make sense? Course videos, class videos, homework solution videos. If you're on my YouTube channel, my playlists, you can bring these up. Now I'm in as me right now, so I can see everything, but I have stuff from everything, okay? If you want to go review college algebra stuff, if you want to go, I don't have a lot for pre-cal, but if you want to go look at other Cal 1 classes I've taught, if like in a year you're deciding to take Cal 2 and you're having trouble in it, I've got like, at least 5 different semesters of Cal 2 videos in here. I have all the homework problems from Cal 2 worked out on video. So I've already done Cal 3 and Cal 2 homework videos. I haven't done Cal 1. So that's why this semester, that's my goal. So there's a plethora of information here for you if you'd like. All right. I hope you like videos. Files. This is where you will find the schedule, course notes. I'm going to go through notes this entire semester. I'm going to have them on this board. That's why the camera's right here and I'm connected to my computer. I'm going to be bringing up notes that look like this. I'm going to be interacting with these documents. Things are going to be moving and changing. All these notes that I'm going through can be printed off. They won't be interactive, but they can be printed off, and at least you don't have to sit there and write all the definitions down. This is what I went ahead and printed off. This is the whole semester, all just the written notes. And they are right here, course notes. All right? Formulas. Everybody is allowed to have, I think it's 6 formula sheets on every exam. These are the only formula sheets you're allowed. Nothing else. You can't have like your favorite unit circle from pre-cal that has your blood on it, everybody has to have the same thing. All right? So fairness is a big thing for me here. So that means you need to open that up, print them out, become acquainted with them, know where certain formulas are. That way when you're taking a test, you know where to go to get it. Yes?
So that means like we're allowed to highlight and write on it, right?
Be careful on that. You can highlight. Do not add anything to it. Don't add a formula. Don't.
No, I understand that. That I understand.
Mm-hmm.
I mean, like, can we write ourselves like side notes? Like, for A, we use this part.
No. Mm-mm. No. It's got to be, again, if I start saying you can write things on it, then what you write might be different than what someone else writes, and then at some point it becomes like this person has an advantage over you, or you have an advantage over someone else. Highlighting is okay. Just don't write anything additionally. Okay? Old exams and reviews. There should be like a warning first. There's nothing that says any of your exams are going to look anything like this. I just have a folder where I just throw a bunch of old stuff. And every semester, I create a new test for that class, for where we are, for how we covered the topics. It's a living thing. So I don't just go take last semester's exams and reproduce them. And I don't want you to be misled by this. But this actually does have old stuff in it, if you want to go look. Clear?
Just a good way to review it.
I'm not going to say that that's a way to review. I'm just going to say this is where I have old stuff. Do what you want with it. I think your best way to review for anything in this class, for a test, is to do your homework. That's where I will start. That's going to be my baseline for my exams, is the homework. Questions?
The last class I took, I was totally agree.
You would totally agree?
I agree with what your statement, that the homework is the best.
Yeah.
Taking a class.
Mm-hmm. Yeah, and I wouldn't count on like a formal review that I'm going to hand to you and like be like, this is the test, just different numbers. That's not going to happen. All right. What I'm trying to help you become is a good student. And to be a good student, you have to be able to prepare. Especially when you get into your major courses, when you're junior, senior level, and you have a midterm and final, 50% of your grade, that's it. Hour and 15 minutes to get 50% of your grade. That'll happen to you at some point. That's pressure. That's, no reviews. That's, do you know how to prepare? Right? I always use this rule of thumb. If you're studying for a Calculus 1 test and you feel like you're ready for the test, you're about 60% ready. When you first have that first feeling of I'm ready, you're about 60% there. That means you got to push beyond that, I think, to be really ready for the test. All right, do I have to go through this whole thing? Please tell me I don't. Whoa, why is it not coming up? Oh, there it is. All right, I do want to mention, I do give you my cell phone number. Okay, that's my cell phone number. I teach internet courses, so I want, to give everyone my cell phone number. My internet students have it. And I have some new technology. I'm big on technology. I like it. So I just got a new Samsung Note 7. Just came out last week. Okay? And yes. Hi, Cal 1. Are you a student? Yes. Come on in. Welcome. Did you get added in late or something? Or? Yeah?
I thought it started at 2 o'clock, so I was waiting outside.
Oh, really? No, it's okay. Come on in. There's a seat right here. Just watch out for the camera. Don't trip. So the reason I got this is because I get a lot of students, especially in class like this, where you're trying to do something and you're writing it down and you're like, I just don't understand what I'm doing wrong. So with technology, a lot of students have been taking a picture of their work and sending it to me, and I'm like, oh yeah, obviously I can see where they messed up right there, but it's hard for me to text that back. So with this, I'll be able to actually, pull it up as a picture right on your work, or just write my own thing back and text it right back to you. Okay, so I want to use this. I paid for it. I may as well use it. So I encourage you to send me text. Just remember though, with texts, like anything else with text, you know how someone texts you and you're busy and you kind of look at it and then you forget about it later? That happens to me too, all right? So if you text me and I don't reply, just send another text a couple hours later or something. Don't, you know what I'm saying, right? Don't what? Yeah, wait a little bit. Yeah, okay. When you text me, if you text me, make sure you put your name, what class you're in. So for this, I would like for you to put your name, Calculus, Calculus 1, Tuesday, Thursday. Just TR. And that you only have to do on the first text. After that, you'll be archived, and I don't have to worry about finding out who you are. All right? You can also call me. I won't call you unless you ask me to, and I will not text you. Text you at midnight on a Saturday, be like, hey, let's talk about Cal 1. Let's do some limits. It's not going to happen, all right? You've got to come to me. I'm not coming to you. All right, so the book, this is what we use for Cal 1, 2, and 3. So if you're all bummed about the cost, this is actually a 3-course. If you take Cal 1, 2, and 3 here, this will cover you the whole way. Yes? Uh-huh. I don't think so. I don't know what the international version is.
Some of them said it's the same thing, just the last chapter is a little different.
I know there's a red version of this book. All I can tell you is that this is what I'm using right here. ISBN, this is what it looks like. If you find another version where only a few pages are off, you're responsible for making sure that things line up. Yes?
Are you opposed to the Kindle version?
I'm not opposed to anything, as long as you know where to go. As long as you're doing these problems, you know what problems you're supposed to do, then I don't mind. Yeah, whatever. If you want to not pay for it and let him pay for it and take pictures of his pages, that's on you, not me. And you could charge him. There's probably something very unethical about what I just said. Okay. Calculators. This is a new policy. I have a TI-89. Anybody else have a TI-89?
I was going to buy one.
Yes, you were going to buy one until you saw this. All right, so I will tell you the same thing I told my other class. This is a policy that I have that is really more for my online students, because I get a lot of online students that I have no idea where they are ability-wise. They come in and take a midterm. I say, okay, start the test, and they all reach for their TI-89s, and they all start punching away. And this is for Cal 1 and Cal 2, and I'm like, it's not in here, right? Cal 1 and Cal 2 is not in there. Well, it is, but you know, that's not the way I want you to learn it. So I put this policy in so that everyone knows when they come for these tests, they can't use them. Because I know people here have them, this is what I'm going to do. First test, the people that have them, I will make a note of who has them, and I'm just going to watch during the test how you use the calculator. If you're one of these people who are just like, I need the calculator to do all the calculus for me, there's going to be a problem. If I know you're doing the work by hand and you're only using the calculator as a check, as a reference, we're okay. I don't want people who invested 150 bucks in that to go have to invest money in another one. All right? Yes?
I don't know how to use them like that.
Pardon me?
I don't know how to use them to make calculus work. Like, I have them there.
You have the TI-89, but you don't have? Okay. So, then I have to worry about you. No, but see, you should learn how to use this. This is an extremely powerful tool. The TI-89, extremely powerful. I wish I would have had this when I was in calculus. This will do everything, just about everything that we do in this class. Now, it won't solve word problems for you, but it'll graph functions and find max and mins, and it'll take derivatives, and it'll even do all the Cal 2 stuff, the backwards stuff. It'll do it. Was there a question? I thought I saw a hand. What up? All right, so calculator policy, description of the course, blah, 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 blah. You will have quizzes. Those will happen at any point in time. You may have an open book quiz, open note quiz, no notes. You work alone, you work in groups. A quiz grade for just being here, a quiz grade for filling out a table about your schedule. These can come in any form. All right, so just be prepared. My expectation is that whatever I assign for homework tonight, you will have done by the next time we meet. If you're planning on, look, I'm only going to be able to study on the weekends, that is not what I expect. I expect that you come to class today, and on Thursday, you are done with 1.3. You've got the homework taken care of. All right? School's like a job, right? Okay, exam 1, 2, and 3 are all 20%. The final is 25%. And the final is comprehensive, but not to the point where it's like every single topic. It'll be like the highlights from each of these, and I'll talk about what those highlights are. Yes?
Are the exams derived from the book more, or are they derived more from what we cover in class?
Well, you know what? That's a great question. And like I said, I make the test every semester. It's a living thing. I always just try and gauge where my students are, you know, and I try and see, like, if I feel like people aren't doing the homework, your test is going to be over homework, you know, because that's what's expected of you, you know. I don't know. I'm not trying to make this impossible, okay? I'm realistic here. I want everyone to do well, but I want everyone to learn. So I'm not gonna give you a test where I ask you these problems that are just like way out there. Like I never even talked about anything like that, or I'm trying to ask you like the most difficult, like I'm asking you to extrapolate like the most complicated idea or concept from something, if that makes sense. I'm gonna keep it on a level playing field of like where the homework level is. But if you're not doing homework, you have no idea what that level is, right? And when I've been doing these videos, I've been like, oh, this problem for sure on the test. Like you're gonna see something for sure like this on the test. Like I'm talking like that when I'm doing these homework solutions. So, did that answer your question? Kind of? A little bit. I think you'll know more as we move on. Technology, I'm recording lectures, quizzes at any point in time. I have very strong policies on texting and being disruptive in class. So here they are. You may use a laptop or tablet to view lecture notes. In other words, I don't mind if what you're doing on your laptop or tablet is related to this class. All right, I don't mind. However, it's very easy for me to tell when somebody is, you know, doing something else on their phone. You know what I'm talking about? Yes? You know. So basically there's a zero tolerance policy on you looking for Pokemons in here.